Let us write a program for Prim's algorithm. Already I have started a project. This is a C++ project I have taken. Here I have a hash defined for maximum integer. So you remember I have shown you that I is a constant, that is symbolic constant. I will use it as infinity. And this is a cost matrix, cost adjacency matrix of size 8 by 8. So 8 rows and 8 columns are there, where I am not using 0th row and 0th column. And the actual cost adjacency matrix is starting from 1 comma 1 onwards, right? From here onwards it's starting. So I'm skipping zeros, that is 0th row and 0th column. Now next is near array that we have already seen on whiteboard, that it will find out the vertices are near to which connected vertex, means the vertices which are already in solution. So and the size is 8. Again here 0th one I will not be using, I will be using from 1 to 7. Then this is for the solution, that is tree is for spanning tree, generating a spanning tree, 2 rows and 7 columns, that 6 will also be sufficient. I'll make it 6. Now here is a main function. In this I will write on Prim's algorithm. So first of all I will declare some variables that are required, that is I, j, k, 3 variables, and u and v are the vertices that I need. And also n, that is number of vertices. We have 7 vertices, and min, that is for finding the minimum every time. So I will take the value infinity. To find smaller value we need to have a larger value with us, so I is infinity. Now if any more variable required I will come back here and declare them. Now let us start. The very first thing in the initial step of Prim's algorithm is to find the minimum cost edge from all these. So as I said, I will be taking the upper triangular part only and then find out the minimum one from there. So for that I will take 2 for loops for I assign 1 onwards, right? I is less than equal to n and I plus plus. This will scan through rows and this j will scan through column, but it should start from I onwards so that it can access only the upper triangular part. Then j plus plus. Then every time we will find out whether cost of an edge I comma j, if it is less than min, then we will change this min to cost of that edge I comma j. And also we will set u as I and v as j. So here we got an edge, right? The minimum cost edge we got. So with these 2 for loops we'll be getting the minimum cost edge in the form of u comma v. So that has to be stored in a solution, that is a spanning tree. T of 0 comma 0 assign u, and T of 1 first row and 0th column assign v. So we got this one. And also we have an array called that is near, and we have to update that array near, right? And before that, in the near array at location that is u as well as v, I should set them as 0 because already we have included them in the solution. So these have to be declared as 0. I've made them, initialize them as 0. Now I have to update or initialize, I should say, near array. So for that I will use for loop for I assign 1 onwards, and I is less than equal to n and I plus plus. And in this one I have to check all other vertices whether they are nearer to u or nearer to v, right? Remember we are doing the initial work. So if the cost of an edge from I to u, if this is less than cost of an edge from I to v, if this is small, first one is small, then we will set near of I as u. Otherwise we will set near of I as v, near of I as v. So even if they are equal also it will set as v, right? If u is less, then it will take u, otherwise it will set it as v. I'll remove these brackets. Now this is initialization of near array. Now we are ready. Now we have to include the rest of the edges. For this the procedure is repeating. So for that I will take a for loop, and for I starts from 1 onwards, because at the 0th location we already have an edge in the solution. So for that we have this I, and I should be less than n minus 1 edges will be taking. So this is I plus plus. Now we have to get remaining set of edges, that is n minus 1 edges. So 1 is already done. So remaining edges we have to take. So for this one, first of all, we'll find out from the near array which one is minimum. So we have to scan through this near array. So for that I will take a loop starting with the j assign 1 onwards, because we are using near array from 1 onwards, so less than equal to n and j plus plus. So what we have to do here is we have to find out which one is minimum. So remember, before writing the condition, I should have minimum already having a infinity value, that is largest value with it. So set minimum to initialize minimum to I, then check here if cost of j comma near of j, right? You remember this code I have already explained you on whiteboard. I'm just typing the code and running the program to give you a demo, and that is less than min. If so, if at all, then we will set k assign j, and also we will change min to cost of that j comma near of j. These two things will do. So with this we'll get the k for which we have the minimum value. And one more thing, inside the condition we have to include only those whose near of j is not equal to 0, right? So this condition is also there. We should not come back to the same edge every time. The vertices which are already included, we should not consider them. So this is the condition, and checking the minimum one and finding the minimum one. So whichever is minimum, that will be set in k. Now, once we are out of this for loop, that is j for loop, we got the answer, that is minimum one. So t of 0th row and ith column assign, we got an edge. So what is that edge? It's k, right? And t of first row then ith column is assigned with near of k, near of k. So we got an edge. And once this is done, we have to modify near of k and set it as 0. Means this vertex is already included. We are not going to use it again. Now we have to modify the near array. See, the first step is to find out the minimum one, that is nearest one, and select it, keep it into the solution. Then now update near array to check whether other vertices are nearer to k or not. So for that, again I have to run a for loop. So this for loop, again I will use j here, j assign 1 onwards, and j is less than or equal to n and j plus plus. And what we do here every time is check if, first of all, near of that j should not be equal to 0, means the vertices which are already included, we should not consider them, and find out whether cost of j comma k is less than cost of j comma near of j. If so, then modify near of j as k, means this vertex is nearer to k. That's it. We should modify all these things. So once this is modified, then again the procedure will repeat. So this is the repetition for rest of the edges, and this is the code what we have seen on whiteboard. Now the remaining part is printing the solution. Now let us print the solution. So for this for loop, I can use I now because I am outside that outer loop. For I assign 0, I is less than n minus 1 edges, we will be having I plus plus, and just we have to print. So C out, I will print the values. First one is t of 0 of I, and second one is, I will put the brackets here, I will put them inside the bracket. Okay, so this will put an opening bracket, then comma, this is the next thing, then after this second one. So as an edge I am showing it as an order pair, so t of 1 comma I. Then let us close the bracket. This is the closing bracket. The next is NL. That's all. So let us compile and see if there are any mistake. If there are any errors, I will remove the errors. Yeah, k is not initialized and used. Anyway, Now let us run the program and see if there are anything left. If any mistakes, I will remove those errors. First, let us run the program. Yeah, this is the output. It is displaying 1 6, then again 1 6. Actually it should be 5 6, right? 5 6, then 4 5. Yeah, 5 6 is coming here, 4 5 is also coming here, then 3 4 is okay, then we have 7 2 2 2 3 also. So there is something missed here. Let us look at it. Condition, yeah, here I am checking the conditions. Near of j is not equal to 0. Yes, here also. Oh, here I have missed the condition. I have to write the condition here also. While initializing the array, I should say near of I is not equal to 0, then only check u or v. This is the first initialization of near array. So here I missed it, so I have written that condition now. So we know well that near of array should not be equal to 0. If it's 0 means we have already included the vertex, we don't have to include it again. Let us run it and check once again. Yes, this is the Prim's result that we have seen on the whiteboard, that is 1 to 6 and 5 to 6, then 4 to 5, then 3 to 4, then 2 to 3, then 7 to 2. Yes, this is perfect. So that's all. This is the Prim's algorithm. So you can type this program by yourself on your PC and you can test it. And it's easy. You can easily rewrite the code once you have done practice on it. And there is a PDF available after along with this video. Check for the resource. You will find a folder on the right hand side panel. So just click on it. You can find the PDF and you can download the PDF. So that's all. Try this program by yourself.